Okay, welcome, and we have here a section, the last section of the lesson. I am going to talk to you here about mechanical energy again, but I'm going to bring in some bit of momentum here. In fact, I want to show you where these two can come together, because that is possible, especially with examiners at the end of the year. In fact, what I'm coming to you with now is an exam question. I took it from one of the previous papers. So let's just see how they put together this question, where you have mechanical energy as well as momentum put together, and you use those principles to answer this question. During an investigation, a police officer fires a bullet of mass 15 grams into a stationary wooden block of mass 5 kilograms, suspended from a long, strong cord. The bullet remains stuck in the block, and the block blade system swings to a height of 15 centimeters above the equilibrium position, as shown below. So we're going to see that diagram. Ignore the effects of friction, okay, and also the mass of the cord. All right, so this is the diagram that tells us what's happening. There is the bullet hitting there, getting embedded into the block, and the system of the bullet block move together to that height. They swing together to that height. Okay, now let's look at the questions. State the law of conservation of momentum in words. Okay, you need to be able to do this. We have done this already, so it's some bit of revision. The total linear momentum. Total linear momentum in an isolated system. In an isolated system, or in a closed system, remains constant in both magnitude and direction. Okay, so this is what the law or the principle of conservation of momentum states or says. Okay, so you can see here there shall be something about momentum. All right, use energy principles to show that the magnitude of the velocity of the block bullet system is 1.71 meters per second immediately after the bullet struck the block. And how do we do that? Okay, then you make use of energy principle, and this energy principle here that is going to help us is that of mechanical energy, that the mechanical energy in an isolated system is conserved. It remains the same in magnitude. Okay, so how do we then answer this question? So we go back to the principle. We say, according to the principle, the sum of potential energy and kinetic energy, which is mechanical energy, here let's say from the bottom, at the bottom should be equal to EP plus EK at the top. Okay? So at the bottom, what do we have? We have got that block at the bottom there, no height above that surface. So it has got 0 potential energy, because potential energy is mgh, plus EK, it is moving, the bullet is moving. Okay, it's half, it hits the block, so the bullet block system is together now. It's half the mass of the object, but it's two objects together now, the mass of the bullet plus the mass of the box. So I will call mass of the bullet 1, mass of the box 2. Okay, V squared, that is kinetic energy there, should be equal to, at the height of 15 centimeters above that position from where the block was, we have potential energy, but at that point at the top, okay, where it stopped, we had no kinetic energy, because kinetic energy is energy of motion. The bullet block system was not moving at that point, so we'll have it that way. Substituting to this, we would say, okay, half M1 is the mass of the bullet, 15 grams, it's 0.015 kilograms, plus mass of the block is 5, V squared is what we're looking for. That should be equal to mass of the system. Again, we know the mass of the system is mass of block plus mass of the bullet, okay, times 9.8 times the height is 15 centimeters. Converting centimeters into meters, you divide by 100, so that is 0.15. Okay, you work this out correctly, V will be equal to 1.71 meters per second, and in that way you have proved that the velocity of the bullet block system is 1.71 meters per second immediately after the bullet struck the block. Calculate the magnitude of the velocity of the bullet just before it strikes the block. Okay, from that point you make use of momentum. Remember, mass of 1, velocity of 1 initial, plus mass of 2, velocity of 2 initial, should be equal to mass of 1 plus mass of 2 V final. Why am I doing this way? Because at the end the bullet and the block are together, so they are moving with the same velocity. Use that, you'll be able to find the magnitude of the velocity of the bullet just before it struck the block. That brings us to the end of this lesson. I hope you enjoyed it, and as for me, Tinyiko Kosa, it's bye-bye.